I do think that the value of thinking differently is one that we need to keep encouraging. It's not just about this diversity terminology everywhere. I mean, there's just a real value to inviting in people who see things differently than you do and really listening to them.
And now, from San Francisco and the UCSF Rosalind Institute, the Health Technology Podcast with your host, Christine Winoto.
When Rosalind Picard joined the MIT Media Lab faculty in 1991, she was given a crucial piece of advice: take risks. As a female engineer in a male-dominated field, Rosalind found the idea of venturing into the emotion technology space daunting. But she decided to take the risk anyways. Since then, Rosalind has co-founded 2 companies and written a book about affective computing, also known as artificial emotional intelligence. This multidisciplinary field provides technologies with the ability to understand and use emotion when interacting with humans. In this episode, Rosalind discusses her groundbreaking work at the intersection of computation, emotion, and AI, and her words of wisdom for the future risk takers of tech. Here's our conversation. Welcome, Rosalind. Thanks for joining me today.
Thank you for having me here. It's a pleasure.
I've been following a lot of your work, and I think what you're doing is really interesting and exciting, especially nowadays people talk a lot about AI. But before we dive into that area, I thought it would be good for everybody to hear about your background. Tell us a little bit about how to get to where you are and what excites you and interests you to be in your field today.
Oh, goodness. There's a lot of crazy adventures I've been on. Maybe the short story is I started as an engineer working to build smarter machines and to build machines that worked like the human brain. I started learning a lot about the human brain. And that got me interested in parts of the brain that I really did not want to be associated with. For example, as a woman trying to be taken seriously and being very mathematical in science, I did not want to be associated with emotion. And I stumbled into the role of emotion in perception and attention and engagement and other areas of computational AI that we were working really hard on. So I decided I should try to get some guys interested in working on that because I wasn't about to touch it and ruin my career, I thought. So I went around, tried to get them to work on it. Nobody would take. I was oddly at this point, I had graduated from Georgia Tech, gone to MIT, done bachelor's, master's, doctorates in electrical engineering, computer science. And I had joined the faculty in a place called the MIT Media Lab, which is this amazing place that actually values the crazier the idea, the more they want to hear about it. And in fact, Jerry Wiesner, the former president of MIT and science advisor to Kennedy and others, had given me this one piece of advice as junior faculty. I said, Jerry, what's the most important thing I should do? And he said, you should take risks. So with his words in my head and with these findings of these parts of the brain that were involved in emotion that I did not want to be associated with, I wrote a book called Affective Computing to get people to take a serious look at the evidence for how affect intersecting with computation and AI and things we could start to measure objectively how that might improve not only AI and more intelligent machines, but how it might improve humans' lives. And that led me on a journey that turned out to actually be quite good for my career, not what I had expected. But I was just, convinced by the science that this was important to start working on and getting it out. And then I had to start getting objective data to measure it. So we started building wearables. People like Steve Mann and Thad Starner were very instrumental in the early days in our lab, helping us build wearable technologies. And the Media Lab is an amazing place where people with every skill set are willing to collaborate and build things that no individual could build on their own. So we built some of the first wearables to monitor the continuously changing physiology that we now know is quite coupled to what's going on in the brain. and to understand those patterns in daily life. And that led to a lot of things I would have never, ever expected to find.
And that's great. And it's interesting when you hear somebody telling you take risks, and then somehow your brain decide, like, I'm going to take risks, when probably before, I don't know whether that's part of your nature to begin with, because to switch to become somebody who's willing to take risks, that's a shift.
Well, I do have to confess, in the last year, I found out who my birth mom was. I always grew up as a happy adoptee, and I still am a happy adoptee, but I also learned that I had a 17-year-old birth mom who was a skydiver, and I used to be a skydiver. So maybe there is a little bit more risk-taking in my genes than just comes from talking to Jerry Wiesner. But I'll have to say that a woman in engineering at the time I was getting started, there weren't very many of us, and to be taken seriously meant a lot, right? We kind of had to, people used to have these signs like you had to work twice as hard to be taken half as seriously. And it meant that, I really didn't want to throw it all away with some piece of work that people would say was embarrassing, which did actually happen. I was at a conference, and one of the major conferences in computer vision pattern recognition, and I heard a guy whispering about 20 feet from me, have you heard what she's doing lately? She used to do respectable work. And I was horrified, right? Because that was exactly my fear if I worked on emotion, what people would say. But 5 years later, that same person came up to me and asked me for my data. He had started working on the same kinds of problems, trying to model emotional changes in human beings with objective data. And that's what we had shown you could start to make some real nice progress on. And then that has now connected up to lots of different medical conditions, mental health and physical health. And it's so exciting to see the revolution taking off now.
Yeah, I think when you're the first in starting something completely new, wasn't it Steve Jobs, or it was an ad on Apple's ad, I think, the crazies. And then everybody started following once you got through certain hump. But I'm glad that you did, because
you're reminding me of their Think Different campaign, where they all the English teachers with their lack of using an adverb. And I remember in the early days they were running that campaign, they reached out to me to be featured. And I said, well, actually, I don't use an Apple machine. At the time, I was using, I think, an HP. I had given a keynote to a bunch of HP researchers, and my machine had blown up in front of the audience. And they said, we can fix that for you. I was not an Apple user at the time, but
now you're convert.
Well, I do. I use a lot of different technologies. I don't want to be in any one person's walled off garden, but I do think that the value of thinking differently is one that we need to keep encouraging. It's not just about this diversity terminology everywhere. I mean, there's just a real value to inviting in people who see things differently than you do, and really listening to them.
Yeah, I think sometimes it sounds easy to say, but I think listening to people who think differently from you can be hard. And I think I wonder if we can train people to be more open about listening to people who think from you differently.
When I got married, my husband banned the word training. He says, you don't train your spouse. And I realized, training is it sounds like we're dogs or something. What we really need to be is liberated to think more freely, be liberated to stop suppressing those crazy thoughts. And, maybe sometimes we need to suppress what we're thinking before we say it. We should suppress some of our speech sometimes, and make sure it's not hurtful more than it's helpful. But in terms of the thinking, we really do need to liberate, too many adults who think I'm not allowed to think that way. I need to just do what's expected of me.
Yeah. So you mentioned when we first start the idea about studying emotion in the machine, and what shift now that there's a lot of people are interested in emotion in the machine, and is it because people finally realize it, or there's a lot of marketing and efforts to educate people to get there. And also why you think emotion is so important for a machine, like the impact that you said is good for the human society.
And let me tear this apart a little bit too, because I imagine your listeners have a lot of different kinds of understanding. I know it's a super smart group of listeners. And yet when I talk about emotion with machines, I break it down into a lot of different kinds of abilities. So, for example, the stuff we worked on hardest in the beginning was for a machine to be able to objectively gather data related to human emotion and maybe better interpret it. Okay. Machines don't truly understand or know anything, right? And they certainly don't feel anything. But they can watch the way things are moving on our face, listen to how things are changing in our voice, and then associate that with labels like, oh, that's a smile, that's an eyebrow raise, that's a pitch going up. And in a particular context, say where you just showed a joke, maybe the eyebrows raising, the smile, the head bouncing, the laughter sound, maybe those things mean that the joke was funny to that person, right? It doesn't tell you what somebody's actually feeling, nor does it enable the machine to really feel anything, because machines don't have a self or emotions in any of those senses. It does, however, give them some symbolic ways to handle data from people. And if you're getting ready to drop $6 million on a Super Bowl ad and you want to know if it's causing people to laugh or not, sometimes what people tell you doesn't actually match what they do. And so the ability to say to people like, hey, would you be willing to let this camera watch you while you watch some of our test content? That actually does give very informative information that the machine can process about human emotion. So that kind of emotion processing, like listening to whether a caller is upset in a call center, taking people with their fully informed consent, and instead of them just filling out a survey 1 to 10, how funny was that? Looking at their response. That kind of stuff is already in use by more than a third of the Fortune 500 companies right now. And, decades ago, this was just a crazy idea.
This podcast is sponsored by Brown Rudnick's Global Life Sciences Group, a team of legal professionals that help life science companies, lenders, and investors around the world turn good science into good business. Learn more at brownrudnick.com. This podcast is also sponsored by Canon Quality Group. Canon Quality Group has been helping medtech startups set up quality management systems for over 10 years. If you're unsure when to get started with quality management in your startup, turn to the experts at canonqualitygroup.com.
A lot of the things that we do is about healthcare innovation, and how is this approach that can be helpful for people with health issues?
Yeah, like healthcare. Lots of ways. In addition to every healthcare company hopefully caring about their customer experience, there are lots of other unique ways that affective data is important for healthcare. I'm involved a lot with wearable data through both my first startup, Affectiva, later acquired by SmartEye, and now through Empatica with an E. That's the Italian word for empathic. And Empatica focuses on wearables that it's not so much about selling the device, although their devices have won a lot of design prizes. It's about collecting and understanding the data, really selling data to people who need clinical quality data, but in a package that looks good enough that you bought it from a fancy wearable design firm. And the data is telling us things about not just the usual stuff that consumer wearables do, like sleep and steps, although we get all that too, but it's telling about continuous autonomic changes, sympathetic nervous system response, parasympathetic, continuous interbeat intervals, and electrodermal activity, as well as pulse oximetry, for FDA cleared, by the way, real commitment to the quality of the data, and giving people the raw data so that different researchers can process it the way they want, or we can provide at Empatica different kinds of processing. And that allows us to see things like what is the role of different flavors of stress in the healing process or in the pain perception process, or in the customer experience process. We're also looking at the way stress interacts with lots of different health conditions. For example, and this was really cool, before the pandemic started, I had this, we've probably all experienced this late at night when you're like really tired and you're pushing yourself to stay up late and you're working on something and you're wondering if you should hang it up and go to bed early because you're tired and you don't know if you're getting sick, or if no, you're just tired because you've been working hard lately and you should stay up and push through it. And I wished I could look at my watch and see, is this like fighting an immune response or is this just fatigue? Well, we got some early data related to the night before people got sick. And it looked like we might actually be able to tell that you were having a response before you got sick. Later, this was augmented with gold standard challenge study data, 2 kinds of influenza, H1N1 and rhinovirus, put up people's noses, not the kind of study I really want to be in. But and the US government and Duke and others who worked hard on this got this data using our wearables. And together, we were able to show that, in fact, we could tell the night before your first flu symptoms that you were, actually having an early response to getting the flu. Later, as you can imagine, when SARS-CoV-2 hit, we repurposed the grants for that. We actually had to stop one of our big IRB-approved studies with Columbia at that point, unfortunately, because of the pandemic shut down a lot of studies. But we were able to restart things with COVID and build a early COVID warning system. So that now is a medically cleared product in the EU, not yet through FDA in the US, but that's called ARIA, ARIA. And it works with our wearable. So again, one of these crazy dreams that comes from late night watching your own data, seeing weird patterns, wondering if there's something real there, and then taking what really turns into years of proper studies to make sure that we're not just getting noise, right? Or, having too high of a false alarm rate. So that now is sensitive and useful enough to be out there actually helping people make better decisions about going to bed early tonight or changing their plans for tomorrow so that they, can get a proper PCR or avoid people who are at high risk.
Yeah, and I think that's good. It's is there a reason why you go to the Europe first rather than here in the US?
Yeah, the EU. In fact, I saw in the Rosalind Institute, you guys already have 50 FDA clearances or approvals, depending, I guess, drug or device. But which is super impressive. FDA, we've gotten 3 clearances that I've been a part of with Empatica, and each one is an enormous amount of work. So we usually go to the EU first, where the EU's standard, it's changing. They're raising the bar even more over there right now. But usually if it's sort of good enough for a gold standard top medical journal in the US, like 3 blind doctors rating your data, blinded to, what you're running on it with your AI, and your AI matches it, and you have super high sensitivity and specificity and, high significance and gold standard, multi-site, all that stuff. Usually all those kind of criteria are good enough for the EU. But my experience with FDA, they always come in wanting something else on top of all of that. And so, you work with them until you've given them that. And by the way, the FDA has been evolving their standards too, learning a lot more about AI, learning how to deal more with adaptive data, which I think is really important for the future and for future health. And also nicely now requiring people to include more diverse participants in their studies, which is really important. So many of the early wearables, the pulse oximeters and so forth, anything with the light-based heart parameters, PPG, photoplethysmography, those have not been as accurate in many cases on people with darker skin pigment. So it's really important that they tighten their standards there.
Yeah. One of the things that you're working on is also with the autistic patient population. I remember when iPad first came out, how excited a lot of the autistic patients, parents, they can use something different as another tool to help them. And tell us more about that work that you're doing in that space.
Yeah, thanks. I have a super happy place in my heart for people on the autism spectrum. We maybe it comes from being at MIT, where we're all where we the more different you are, the more we say you fit in at a place like MIT. I have learned so much from people on the spectrum. Their minds work in wonderful and different ways, and I just treasure the time I get with them. I have learned so much from different sensory experiences to different ways they take input very literally, different ways they see social interactions, and different ways they communicate. Lots of amazing, exciting, wonderful things to learn about the human mind from getting to know people on the spectrum. They have hugely influenced our work. For example, in the early days, when we started building systems to read facial expressions, one young man showed up at my office and said, "Oh, you're building a tool that helps a computer read faces. Could you help my brother?" And I'm like, "Tell me about your brother." And he starts telling me about how he couldn't interpret facial expressions in a conversation, how he was autistic. And so we started working on tools to help people like him. And while we were hanging out with these folks and getting to know them, which is a wonderful value I've picked up from the Media Lab community, right? You don't just walk in with your knowledge as a scientist and kind of impose your solution on people. You spend time with the people that you think you might be able to help, learning from them and co-designing with them. Like what would they really like to see? Not that they know what's possible. So there's kind of this dance, right? Of, here's some crazy things, or imagine you could have anything at all, and iterating with them. And at one point, so many of them wanted a tool, and we built tools for them. And today, now these tools are out there, which is awesome. But one day, one of them came to me and said, "Roz, you have it totally wrong." And I'm like, "Okay, what is it? What do I have wrong this time?" And she said, you think my biggest problem is understanding other people's emotions, but that's not my biggest problem." She said, "My biggest problem is you're not understanding my emotion." Oh dear. So I shrunk about 2 inches tall. Great. I work on this, and I'm so sorry. I'm sorry. I haven't understood your emotion. What is it I haven't understood? And she said, "It's not just you. It's everybody's misunderstanding my emotions." Not sure that made me feel much better. But she said, "What you're missing is my stress." And I realized, we all kind of have this notion of, we think we're pretty good at seeing when somebody's stressed. But she had an atypical way of showing her stress. And she was having massively more stress than most of us, are aware of. And she said, talking to other people on the spectrum, this was very common. And in fact, now that I've talked to many more about this, I think this really is very common. Actually, it's become hugely common in our society today, too, just among young people, especially post-pandemic. So as I started to learn more about what we could do to help her stress be better understood, I realized some of the lab-based measurements we had been using of physiology could be very useful for getting that fight or flight response and those real-world naturally occurring forms of stress. But those sensors involved wires on your fingers. You couldn't move your fingers. You couldn't even type without a motion artifact in them at the time. You couldn't wash your hands. They really got in the way. And supposedly they really only worked on your fingers and the bottoms of your feet. So we built versions for those places. We even did work with infants who were at risk of autism with rigging up baby socks with these sensors. I'll never forget the day the accounting people came in and said, "This Professor Picard, she just ordered 36 baby socks. Like something is wrong. We can't allow MIT purchasing to be buying baby socks. Like, somebody stop her." And I showed them how we were, doing these soft wiring and measuring, trying to find a really friendly way to get data from these children. They finally approved the order. I said, "I'll just, it's okay." So
tell us why it's important for that individual, for you to understand their stress and to measure it, and how that helped that person.
Yeah, one of the things, it's funny, I wish I'd learned this earlier in life, but it wasn't until later in life that I learned how important it is for people to feel understood. It's one thing when somebody says to you, "Oh, I understand," right? But I mean, how do you know if they understand? But when they say back to you, you know, "Oh, wow, that sounds like that could be really painful, what you're going through," or "Wow, that could, I, if I were in that situation, I might feel a lot of fear, right? Or I might feel betrayal, or I might feel hoodwinked," or like when people start to put words around whatever it is that you're going through, the stress, the negative experience, or whatever, the external validity being kind of held up in front of you is very it's hard to describe, but psychologically it's very freeing. It's very affirming. It's kind of liberating. It lets you let go of something that might have been kind of grabbing you and controlling you, see it outside of you, and then that usually frees up the person to problem solve around it a lot better, not get stuck in that emotional state, but move past it. So when another person understands truly, or maybe they don't really understand, like a man may have never understood childbirth pain, but if he can still try to put it in words and describe some similar pain he's experienced and reflect that back to you, that is incredibly therapeutic for people. And even when a machine does it with machine empathy, we've had machines do this, it's incredibly helpful for the person who feels understood, even if they're not truly understood, right? But the words allow them to see the state of themselves outside of themselves.
So when you're saying that you're using the babies who are have a higher risk of being autistic, like what are you measuring and what you're trying to achieve from that data that you're trying to collect with the babies?
Yeah, so we've done a bunch of studies with infants, and there's a whole lot more to do. It's an incredibly exciting area for future research that I am super excited about. Some changes that are about to happen there that are going to enable a lot more work there. In the beginning, what we were trying to do was to see if they had different kinds of autonomic responsivity to pain. Not that we want to hurt any babies. We were going into situations, into the medical environment where they are naturally inflicting pain, like a heel stick, or a regular doctor's visit, or shots that the infant's getting. So we do not want to add more pain. We're looking at where there is naturally occurring pain and other sensory experiences. So for example, when they lay the baby down and they take the diaper off, that is an activating experience for the baby. What does that autonomic profile look like? And then we want to characterize these profiles across lots of different kinds of infants and understand the distribution of typical responses and the distribution of atypical responses, and then see if any of those atypical responses are associated with other developmental issues.
And so the goal is to have the tool to diagnose early?
Yeah. The goal would be, well, there are a lot of things. We would want to understand if there was something that was atypical that was associated with leading to a problem, where there's also the opportunity to intervene earlier. Now, what the right way to intervene is still open research, right? But you can start to imagine a lot of things. So, for example, if this is a child with hypersensitive responses to pain, then don't say, "Hey, this child is overreacting." Like, just say, "Look, they're wired differently. We may need to do more to pre-calm them, to set up expectations, and to manage the stress afterwards, right? So that they learn to associate a less threatening, to not associate threat and fear with this also, right? Because when you start associating threat and fear with a certain stimulus, then you build anxiety even before the stimulus, and then the overall pain profile is even larger, right? So we've been monitoring this. We're seeing like responses that precede the pain stimulus. They're like already going ouch before you even touch them. So a lot of pain, I think, is also this fear and anxiety before pain. And if we could not just measure the pain, but understand that whole experience, we might be able to improve that. And that's true of all people, not just infants.
Right. I think it reminds me when I have a child And I remember seeing so many different kids. They have different personality, but it's almost like everybody's react at different level on different, like some kids are more open to uncertainty and some have to be like rigid. So as a society, we always say, they have different personality, but which is true. They have different.
And we think like in autism, when a kid hears, like I remember one little boy heard the screaming of this baby in this room. And then afterwards, he didn't want to go back in that room. And I don't know about him, but I know people like him who have described that the sound was so painful that it was like a traumatic, painful experience for them. And so it's actually very smart that their body would not want to go back in there, right? For that. Whereas the rest of us are like, hey, get over it. What's the issue? Get the kid back in there. We don't understand, right? We're not understanding their stress and their pain. So when these wearables and these tools help us see objectively that this kid is experiencing this at a very different volume, at a very different autonomic level, then it kind of takes away the argument about like, does the kid just
you're being difficult or you're not being difficult?
Yeah. It's like, hey, let's stop blaming the kid. Look, he's just wired in this different way. Let's think more constructively about how to help him manage the fact that his sensory experience is so different.
Well, that's really interesting. The more I feel like I'm now thinking way back, there's a lot more conversation now around mental health. There's a lot more term on how, and I think personality also is getting a lot more of, defined, like not defined, that's like, understanding like what this is are. And I think having a tool to kind of make it more objective, take away from the blame, I think, hopefully.
Yeah, there's so much blame and shame and all of this, and it's like, well, that's not productive. I never forget one of the first times we showed some objective affective data to a big high-level decision maker in a company. And he said, on hindsight, you've just shown us something we already knew, but we realized we didn't believe it before. And now we believe it. And I was a little annoyed, right? Oh, what do you mean you already knew this? But the point was it made a difference in how they acted. Before they kind of thought maybe that was true. And now it's like, okay, we have all this reasoning about it and we have this objective data. I mean, not that data is always 100% perfect. It's not. But when you look at the whole picture and you see that and it's compelling, sometimes that makes it easier for people to just move forward, right? Stop being stuck, get unstuck, move forward, get things fixed.
You're in the academia and also you're part of the startup innovation. I'm just trying to do you see the difference between where you are sitting in academia versus how to start up? And what's the difference? Like what areas that it works well in academia that translate very well in a startups environment?
Yeah, so I am full-time at MIT in the Media Lab now. I also consult for Empatica, and I do some other consulting for other large companies in the wearables and healthcare spaces from time to time too. I'd say the risk-taking works very well in the early phase of the startup and in academia. One of the things that also works well if your startup is going FDA or medical is, certainly with my academic background, although not with all of them, is a real dedication to rigor. And some would say a dedication to pushing through pain, right? Because some of that process is so painful and so miserable that maybe one of the best predictors of whether or not a person's willing to do it is, did they already get a PhD from a place like MIT, right? Where it's so hard that if you've done it in the top program, like in our CS program or EE program, or our Media Lab, we have a super tough program. Then when people have done that, it's proven that they can push through and persevere and handle a lot of things that might derail other people. So those things I think carry over well. If you're investing in people for a startup or considering who to partner with in a startup, these are qualities that work. I'd say one of the things that I see a lot of that I would recommend against is people who haven't yet settled on what people need to have. There's a lot of aspirational, oh, it would be nice to have. Oh, it's cool. Maybe we could do this. And I think that still belongs in academia. And when that goes over to industry, I don't know about, maybe some people have made a lot of money off of that, but I would not personally invest in that, because so much of that is like, the hammer in search of the nail, or it's just like, it could be a cool idea, could be really amazing technology, super neat math, super brilliant insights. But it doesn't mean people need it in the form that it's in, or that they're going to pay for it, that's really going to solve a pain point or a real need out there. So that's one of the things I've learned to really look for under the hood. Like, is there a real business here? Is there a real, problem out there that people are willing to pay to solve with this solution? If not, I think it needs to stay in academia for a while.
Not quite ready yet.
Yeah, keep playing.
So you mentioned earlier that being where you are, there's a lot of challenges, and I'm sure there's a lot of time things did not turn out the way you wanted. And then what do you learn, and how do you overcome that? Like, how to keep getting up and keep knocking that?
Oh boy. I'm teaching an AI mental health class right now, and our last lecture coming up next week is touching on this topic of meaning and purpose. It's one of the 5 pillars of well-being in like Marty Seligman's PERMA model, and work based on early work by Carol Riff and others, where it's not just about being happy or engaged or achievement or relationships. There's meaning, and where does that come from that sustains you, right? When things are empty, when your tank is empty, you're burned out, and you just took another hit. You got another rejection, or another, investor or sponsor or somebody pulled out because, their account tanked or something. So there certainly are a lot of hits, and I've had a long list of them. The first thing I do is I don't count them. I don't keep track of them. One friend telling me how many rejection letters she had, and I'm like, I have no idea how many rejected whatever's, papers, proposals, where I do not count them. I do not keep track of them. I'm always looking for the next, I want to learn from them, but once I've extracted what I'm learning, like those aren't on any lists. It's more about moving forward. And I think drawing energy and inspiration, I think in my personal experience, I have to get it from something much bigger than myself and my friends and my network. And the models of meaning we've been studying almost always point to a higher purpose, something beyond the friend group, something beyond ourselves. And this may not be a very popular answer in the Bay Area these days. But years ago, I switched my thinking from saying, I don't think there's anything out there, sort of this atheist thinking, to, there's actually a lot of interesting evidence that there is something out there. And I certainly see amazingly more resilient lives that turn to that. We see more data that people who have like regular practice in a spiritual, most of the data happens to be with Christian church communities, but people going to regular religious practice, and they have better health, even controlling for their health going into the study, better lower suicide rates, better mental health, better physical health, all kinds of things. And if you look at the active ingredients of that, there are a lot of fascinating components of it. Yes, there's a social component. Yes, singing. Yes, forgiveness. Yes, community support. But also something outside of all of our humanity that seems to be not just awe-inspiring, but also a source of strength. So for me personally, I have switched from, yuck, I don't want to have anything to do with all that stuff, to, wow, like this makes a difference in my life. And so I highly recommend, if people are feeling depleted and really unable to find what they need to bring joy and sustain themselves, that they turn to some of these faith communities and, really seek I'll say the G word, seek God, seek what, maybe you use a different word for God. And maybe your concept of God is this little childish thing that needs to go away. You need to believe in something bigger.
Yeah.
But I do find that, if you expand like physicists to before the origin of the universe, outside of space and time, something grander and greater than all that science and our ability to comprehend and think limits our thinking to. If you allow, again, that liberty of thought, you can find much greater strength.
That's great. Well, thank you. Thank you for sharing that.
Thank you for listening to another episode of the Health Technology Podcast. We want to thank our executive producer, Herminio Neto, and our podcast engineer, Andrew Rojek. If you enjoyed this podcast, be sure to subscribe and leave a review. The Health Technology Podcast is available on all major platforms.